We really like to constantly be learning new information and sharing information, and Facebook is one of our places that we do it. So if you check out our Facebook page, you can see there's an article we posted today that's very, very interesting that we'll talk about for a little bit. The article is from the Washington Post, and the article title is "These 3 Earth-like planets may be our best chance yet at detecting life." And then there's this image here. Really cool information that came out. There are 3 exoplanets, and maybe you can tell me a little bit maybe about what exoplanets are. I don't know. But these were found orbiting the star TRAPPIST-1. And the way that we can tell that they're there is that, so when we're observing the star and the planets are orbiting around it, when the planet goes around the sun, and actually you can see with the image, maybe this is better. Let's look at the image on my computer so you can kind of see what ends up happening is that star kind of dims a little bit to our vision. And so by looking at the dimming, we can kind of calculate the size of the planets and then also their distance from the host star. So maybe how far away is it from rotating. And actually these 3 planets that they found, they can also pretty much predict with confidence what the composition of the planet is, if it's liquid or rocky or whatever, based on how far from its sun or its star it is, and the dimming basically of that. And they're saying that they think that these 3 planets are actually tidally locked, which means that, correct me if I'm wrong, Sam, means that they don't rotate with the tide, exactly. So that they have one kind of like our moon, right?
Mm-hmm. One side always faces the
one side always stays facing the star. So there's a sunny side of the planet and then there's a dark side of the planet as well. But yeah, really interesting. They're thinking that the conditions on the planet based on their distance to their star would be very close to potentially Earth.
Yeah, it's so interesting. So let me mention a couple things or just jump off what you said. So exoplanets refer to planets outside of our own solar system.
Okay.
So these are. Exo outside, I think they'd be endoplanets if they were inside.
Makes sense.
Also, so planets form when stars collapse. So you get these supernova or just star explosions. And when that happens, a star will scatter all of its guts across a really wide area.
Ew, star guts.
Star guts, exactly.
Gross.
And the force of gravity will cause all these things to start spinning in on themselves. And essentially what you'll have is you'll have denser elements closer toward the center of the explosion over time. And then less dense elements will move out away. So you start off with, like, in the infancy of our solar system, the progenitor of our sun, so a larger star that exploded and left our sun there in the middle, there would have just been a really, really wide disk of debris and dust. And the deal is that as that disk starts to spin, as I said, the dense elements make it closer to the center, the lighter elements make it further away. And in our solar system, what this did was it created 3 or 4 rocky planets. Or terrestrial planets. So we have Mercury, Venus, Earth, and Mars, which are all rocky. And then as you get past that, you get the gas giants. So Jupiter, Saturn, Uranus. And really the idea is that they're just formed of less dense material. So the gravitational pull that caused the spinning of our solar system pulled the heavier stuff closer and the lighter stuff further away. So I assume that's how they're able to make a prediction in the case of these planets that, based on their distance and the size of the star, they must be rocky planets.
And they were saying that these planets are very close to their sun.
Right, which makes sense,
it orbits their sun in just a matter of days. So they are close. So that would make sense that they are rocky. But they are thinking that the first 2 planets are still too close to the sun to actually have water on the surface.
Yeah, and that would be the issue. And the other thing about being tidally locked that would be a major issue is one side of your planet would bake while the other side would freeze. So I almost wonder whether there would be, like, around the sort of a vertical equator, right? The point where the hot and cold sides meet, there would probably be this area of sort of moderate temperatures.
Right.
They're always moderate because one side is always facing the sun and one side is always facing the dark of space.
Would you get a lot of weather there?
Yeah, I would
Yeah,
assume,
just because of the stark difference between the temperatures?
yeah, that makes total sense, right? Since intense weather comes from the mixing of, and I'm speaking about something I do not know right now, but at least based on my understanding of the way Earth works, right? When you get mixing of hot air and cold air, you end up with intense weather systems,
right,
storms.
right.
But also, one thing that I don't know about these planets is how much of an atmosphere do they have?
Right.
So there's not even going to be this hot air, cold air difference if there is no atmosphere.
Exactly, that makes sense.
Yeah.
Atmosphere is what holds the temperature, yeah.
Exactly. So it's funny because I guess as I'm reading, so it's possible that certain regions of this planet would be just right for water, like these sort of thin strips between the hot and the cool. But when we think about, I mean, we do say all the time, generally speaking, planets that are similar to Earth are the ones that are going to be most likely to have life.
Yeah.
But these planets don't seem that, or we're making a big stretch to say they're similar to Earth, right?
Right.
If they're not, if they're tidally locked, right? If they're facing one direction all the time, that's a major difference right there.
Not very much like Earth, yes.
And then there's the difference in the sun. So this is a dwarf star. It's, let me see, there was a number here, but it's like 1/8 the power of our sun. I read that somewhere. I'm not sure where I say that, but oh, here we go. So it says it's 1/8 the mass of our sun and much cooler. So like the distance from our sun to the Earth is going to be much larger than the distance from this sun, TRAPPIST-1, to a planet that might have life. That planet could be much closer because the star is less strong.
Much cooler, yeah.
So really interesting. And then, you just think about the way that scientists are currently looking for life within our own solar system. There's lots of faith that we're going to find some kind of microbial life on Mars. Although some people think it's impossible, there's lots of folks that think Mars has this extensive system of lava tubes, so essentially caves. And there's a belief that that would be an area where microbes could be shielded from sort of the harsh weather on the surface of Mars. And so I think that the chances of finding life in our solar system are reasonable, but it's very cool that they're looking further to try to find life more like what we have here.
Somewhere else that recreates very similar conditions to what we have. So I wonder if our best chances is looking elsewhere or looking closer to home. Like
Right, and it'll probably be different types of life that we find. I mean, one of the most interesting things about this is that we're just so obsessed as a species with is there life
elsewhere
out there, because it really is, given the size of the universe, it's far, far more likely that there's life in many places in the universe than that it only happened here. But of course, distances are so vast. They talk about these as being very close. The 3 planets are close by, just 40 light years away.
40 light years away.
Is what our
They're
research
super
says.
Close.
But that is like, traveling at the speed of light. It would take you 40 years to get to the planets. So that's hardly something I would call close.
Really far, right? But comparatively, maybe.
Absolutely.
Yeah.
Subscribe!
Come on, push the button.
You know you want to.
Do it.